we have discussed the load carrying capacity of a pile group by the two criteria. Now one more numerical we will cover over here. Sometime instead of giving the soil parameters and you have to find out the load carrying capacity of a pile group, sometime the load coming or expected over the pile group is given, and in that case you have to design the pile. Now here there is a pile load which is expected to come over the foundation is 3000 kilonewton, and then the soil is given as 20 meter. There is a soft clay. Then the average unconfined compression strength is given as 70, right? So here there is a group of the pile. Nothing is mentioned where how many number of piles you have to provide. In such cases, the given data is that nothing is mentioned. Nothing is mentioned where you have to find out the load expected to come over the foundation, including the pile cap, is given as 3000. Including the weight of the pile cap is given as 3000 when there is an average cohesion of 70. C is equal to 70 kilonewton per meter square is given. Then the hard strata is available up to a depth of 20 meter is true, which is extended below that there is a rock. So this much is given. Now in this case, when you have to find out or when you want to make a design of pile group, design of pile group includes first, it includes the diameter of pipe, then L is the length of the pipe, then N is the number of pipe. And the most important, you have to assume the spacing between the pipe. So there are four unknowns, but this S is directly depends upon the value of S. So again, there are three unknowns that we have to consider. D is the diameter, L is the length, and N is the number of the pipe. So in such cases, what we will do, we will assume two things. So in this case, we will assume the diameter and length, then we will calculate the number of pipes. Now here, as we know, the length of the clay layer is extended up to a depth of 20 meter. So naturally, we will never reach to that. Here the hard strata is at 20 meter depth, and if suppose we have considered L is equal to 10. So here I will just consider this is 0.5 meters. Assume this is 0.5 meters, and this there is 10 meters. If suppose the length of the pile is 10 meter, and the clay soil is extended up to a 20 meter depth, so naturally whatever is the load carrying capacity, that will be assumed as a friction pipe. Friction pipe as pile not reaches to hard strata. As the length of the pile is 10 meter and the length of the hard rock is at 20 meters, so it is assumed that the pile never reaches to the hard strata, therefore it will be assumed as a friction pile. In such is equal to 0. Right? So we have assumed these two parameters and now we will calculate the further. In such cases, the most important is the number of piles that you have to calculate. Right? So here we will just assume the spacing is 3D. So it is found to be 1.5 meters. 1.5 meters. Then further, when we will calculate the load carrying capacity of a pile group, then what is the criteria? Here we will just consider this is QU for group, which is QB plus QS, as QB is equal to 0. So whatever is the capacity is due to QS, and when we are considering it as a group, when we are considering it in a group, we will calculate it by the first criteria. We will calculate it by the first criteria. So what is the first criteria? In such cases, we will consider QU of an individual multiplied by number of piles. So here we will just consider this QU group, that is allowable load is given. Allowable load is given. So here what is Q ultimate? Q ultimate is equal to Q allowable. Q allowable is equal to Q ultimate divided by factor of safety. Q ultimate divided by factor of safety. Here the factor of safety is given as 3. Factor of safety is given as 3. So here we will just consider this is Q allowable, which is equal to Q ultimate for individual multiplied by number of piles. So here we will consider this factor of safety. And for which factor this factor of safety is applicable? The factor of safety is applicable for the cohesion component, because that is the only component of the shear strength. So in this case, here we will just write down 3000 is equal to, if suppose we will consider it is a friction pile, so it will be C into alpha into pi d L. C into alpha into pi d L into number of piles into number of piles. Again, when we are considering alpha is unity, in such cases, what is it? It is 70 divided by 3 multiplied by pi into 0.5 square into 10. So this is the value which is n, which is considered as n, and here it will be equal to the 3000. Now the n value is found to be 16. In this case, it is found to be 16.37. So we will round up it on the lower side just to take the square root of pi 30 by square root of pi by 4 by 2. So in this case, we will assume this is a 16 number of piles. This is 16 number of piles. This 16 number of piles we will take and round up the value. If suppose instead of 16.37 we have taken 6, so in such cases we have to increase or modify the length or D. Whatever we have assumed, we can modify this or this. But this is more comfortable for us. Instead of that, we will go for the length because length is an independent parameter. But here we have considered spacing is equal to 3. So in that case, these assumptions again we have to modify. Therefore, we will modify the length. Next is modify the length. And therefore, whatever is the modified length, that modified length is equal to L modified is equal to 10 into 16.37 divided by 16. So this is found to be 11 meter. 11 meter. So this is the modified. Now whatever assumptions or whatever calculations we have made for considering the first criteria, we have to check it for the group criteria whether it is safe or not. Right? Whatever we have considered, that again we have to take into consideration for the next. So find out, check by second criteria. In this case now, we will consider there are 4 piles which are arranged in a square pattern, and this is the spacing. So what is B? B is equal to 3 times S plus D. So it is 3 into 1.5 plus 0.5. So it is found to be 5 meters. It is found to be 5 meters. So what is Q group then? Q group is equal to C into alpha into 4B and N. So here this is 70 into 1 into 4 into 5 into 10. So this Q group is found to be again here we have taken into consideration the factor of safety. Then only it will be Q reliable, because we have to consider and compare with the Q reliable. So here it is found to be 5191.7. So this value is greater than 3000. This value obtained is greater than 3000, means this is safe. So whatever assumptions we have made, that are the safe one. Therefore, whatever assumptions we have made, that it is correct, and then we can go with this given parameters where there are 16 piles of diameter 0.5 and length is 11 meter. Previously we had considered 10 meter is the length, but when the number of piles are more than 16, we have rounded up it on the lower side, and therefore we have modified the pile length. Okay. Now this is the first criteria in which we have calculated the load carrying capacity by the static formula. Now we will discuss the load carrying capacity by the dynamic formula. So what is dynamic formula? Dynamic formula is basically the load carrying capacity of a given pile calculated by the penetration resistance in consideration. Taking into consideration the penetration resistance. So here load carrying capacity of pile by dynamic formula. So the formula is based on the principle that resistance against penetration, resistance against penetration. Then second, there the load is dynamic force is taken into consideration. Then it is for which type of soil, whether it will be for the in situ pile or board pile, or whether it is for the driven piles, that is precast pile. So it is applicable for driven called V1 and precast pipe. V1 and precast pipe, right? Then fourth one is V1 and precast pipe, and here in which condition it is suitable or in which condition it is considered to be ideal one. Now tell me whether we will consider this is the pile and this pile we are trying to insert into the soil by giving a hammer blow at its top. So this hammer blow shows or provides a dynamic load, where this is the precast pile which is inserted into the soil. Now here, if suppose this pile is inserted into the saturated clay, this pile inserted into a saturated clay, that saturated clay shows more resistance due to the existence of poor water pressure. Due to the existence of poor water pressure, it shows more resistance. Means in this case, suppose for the penetration of this pile, it may require 15 number of blows. So due to the seepage pressure or due to the poor water pressure, that 15 may be increased to 18 number of blows, but actually after the desiccation of the poor water pressure, the 15 blows may be required. In such cases, the dynamic formula not gives you a Q rate value. Second, in which type of soil it will be suitable? It is suitable in good draining soil or particularly in sandy soil. There is no existence of poor water pressure. So what is ideally suited for? Material is good sand. And where it will not be suitable? Where it will not be suitable? Not suitable for saturated clay. Lands not suitable for saturated clay where there is an existence of poor water pressure. So these are some of the features of the test. These are some of the features of the test. Now here, what we are taking into consideration basically, when there is a pile which is being inserted into the soil. Here suppose this is the pile. This coil is having a pointed shoe at its bottom, and this is being, we are trying to insert it into the soil. Here we are trying to insert it into the soil. Then naturally this is precast driven pipe. Precast driven pipe. Now this given pile we want to insert into the soil. So naturally, suppose this is the pile which I wanted to insert into the soil. So I have to apply certain load on its top, and that is called as the hammer, which is required to penetrate. So here this is the hammer or the ram, we can say. Ram of hammer, and the weight of this ram is assumed to be W. Suppose this weight is assumed to be W. Then due to the driving or due to this weight is falling at the top of the pile, so this is called as free fall. This is called as free fall. Free fall, which is denoted by H. So what is meant by driving energy? Driving energy is the energy imparted by the hammer. Energy imparted by the hammer at the top of the pile, and that will be rated energy, which will be showing the product of W and H. So here, suppose I will assume this as the energy which I have given to the W into H. So this is the rated energy which I am giving to the pile. so that it will be entered or it will be penetrated into the soil mass, right? Now, due to this driving, suppose there is a penetration of the pile. Suppose this is the penetration of the pile, and this penetration is called as S. This S is the penetration of pile per hole, and it is assumed to be some last number of holes or for the last penetration. Now tell me, in this case, what is work done and what is energy applied? This is the energy applied, and this is the work done. This work done is in the form of penetration of the pipe. So these are the different parameters that we have to take into consideration. Now with this, there is the energy imparted on the pipe. Then there is a penetration which is in the form of work done. Then one of the very important terms that we have to take into consideration, that is the hammer efficiency. Then efficiency of hammer blows. Efficiency of hammer blow. Many times we know that when the machine is in an ideal condition, it shows its or it will shows its better effort or better results. But after a number of years, due to its continuous deterioration of the machine, the efficiency of the machine is getting reduced. And in such cases, we have to take into consideration the efficiency of that particular hammer which we are using for penetration. Many times, the number of blows or the hammer blows also we have taken into consideration the efficiency. Because many times, by driving it, suppose there is not a proper contact of the pipe and the hammer, or the CG of the hammer is not coincide with the CG of the pipe. In that case, your efforts may lost. Therefore, the efficiency of hammer blow we have to take into consideration. Secondly, and very important, when we are driving the pile into the soil by the hammer, what may happen? Suppose I will consider this is the pile, and this pile I will insert with the help of a hammer. So, due to this impact of the hammer, sometimes the top of the pile is getting damaged, sometimes the top of the pile is getting damaged, and therefore it may lost the material, and therefore always remember that while the pile is inserted into the soil, the pile cap is provided. Here you can see this is the pile cap which is provided at the top. This is the pile cap which is provided at the top. Now, when this pile cap is provided, in between these, the cushion is placed. Here you can see the cushion is placed. Now, this cushion is actually protecting the top of the pile by the hammering. Due to continuous hammering, due to a heavy hammer, sometimes the top of the pile is getting damaged. Therefore, this dolly or the helmet, which is called as helmet, which is placed over here so that the pile top is not getting damaged. So during driving, many times the energy may be lost. And over here, these cushion may be subjected to heat generated due to driving. Cushion is subjected to heat generated by the driving, and in that case, there is a burning of this or fire. It may catch fire due to a heat generation, and therefore some energy may lost in the heating or the burning of the cushion. So that all points we have to take into consideration when we are calculating the load carrying capacity of the pile by the diagonal formula, right? first, this concept was given by this concept was given by the ENR formula, engineering record formula, that is called as engineering record formula, or it is also known as ENR formula. So first formula is ENR formula, that is engineering use record formula. Engineering use record formula, which is called as ENR formula. Now here, what is the energy given? What is the energy given? Energy given is the is equal to what then? Now here, energy is given by W. What is W? W is the weight of the hammer. Then H. H is the height of the free fall and efficiency of hammer. Efficiency of hammer. And then we will just consider which is resistance given by, or the resistance given by the pipe into S plus C. What is S? S is the penetration of the pipe for a last few holes, and C is the constant which we are taken into consideration. Now, what is this R? R is resistance. That we have denoted by Q. And therefore, what is Q then? Q is equal to W into H into efficiency of hammer upon S plus C. S plus C. So by this way, we can calculate the load carrying capacity of a pipe. Now what is this? Here, this W is weight of hammer in kilonewton. In kilonewton. Then H is height of free fall. In centimeters. Then efficiency of hammer, which may be given in percentage. Then S is the penetration per block. Which is again given in centimeter. And then C is constant. Now, how this constant is being determined or taken into consideration? This constant is again depends upon the type of hammer that you are using to driving the pipe. Now, what are the different types of pipes, or what are the different types of the hammers which are used? Hammers, first is a drop hammer. Drop hammer. So this drop hammer is exactly what? Drop hammer is the hammer which is being lifted manually and dropped by gravity. Lifted manually and dropped by gravity. So this manual is hammer is a very ancient type of hammer which people are using from the ancient days, where just manually we are driving the force on the top of the pile and the pile is inserted. So that pile is called that hammer is called a drop hammer. Then the another is single acting, or that is steam hammer. Then compressed hammer, compressed. So these are the fuel which is used. These are the fuel used to drop the hammer into the soil. So these hammers are maybe a single acting hammer or it may be a double acting. So here these are single acting. Single acting hammers are lifted lifted manually and dropped by gravity. Lifted manually and lifted with the help of a fuel. Okay, automatically lifted up, mechanically it is being lifted and dropped by gravity. Lifted mechanically and dropped by gravity. Dropped by gravity. Then the double acting hammer. What is meant by double acting hammer? Double acting hammers are both the operations are done mechanically. Means lifting, dropping. Both the operations are mechanically done. Lifting and dropping both are done mechanically. Both are done mechanically. So these are hammers that are the double acting hammers are considered to be a more effective one. Double acting hammer where both the operation lifting and dropping both the operations are done mechanically. In that case, that hammers are considered to be a more effective one. Considered to be a more effective hammers. And the next type of hammer is a diesel hammer, where diesel hammer where diesel is used as a fuel and that are very compact and portable. Portable and more convenient, as it is very portable one and fuel is available in everywhere and the small equipment can carry everywhere. So there this portable diesel hammer is more portable and effective because the number of blows are very short and quick. Therefore, diesel hammers are more effective type of hammer. So here what we will discuss, C is what? C is basically the constant which is depends upon the type of hammer. Now if suppose there is a drop hammer. Suppose this hammer is a drop hammer. This C is taken as 2.54 centimeters. And when there is a single and double acting hammer, single and double acting steel hammer, the C is taken as 0.254 centimeters. So this formula is called as the ENR formula, which is Engineering News Record formula. This formula is called as Engineering News Record formula. Right? So in this type of the formula, in this type of the equation, efficiency of hammer is only taken, but the efficiency of hammer blow is not taken into consideration, where the method is very approximate method. Further, the formula is being modified and then it is called as Modified Engineering News Record formula. Then it is called as Modified Engineering News Record formula, where the same parameters are given, but here some additional thing is added and that is considered as a modified ENR formula. Modified Engineering News Record formula. Here, in modified ENR formula, that is, in modified ENR formula, the different losses are taken into consideration. So, what is the assumption? Different losses are taken into consideration. Then coefficient of restitution is also taken into consideration. Coefficient of restitution, and that is denoted by E. Coefficient of restitution means due to the driving of the pile, there is a compression of the pile surrounding soil, and all that is being taken care by the E, that is called as coefficient of restitution. Now here, one more thing come in picture, that is the weight of the pile. Weight of pile cap, which is denoted as P. Previously, there was only a weight of the hammer is taken into consideration, but here, with the weight of the hammer, the weight of the pile cap is also taken into consideration, and therefore the formula is QU is equal to in the previous one. In ANR formula, that is very approximate formula. Therefore, the factor of safety over there is considered as 6. Okay. So in this case, this is W into H into efficiency of hammer upon S plus C into W plus E square P, W plus E square P upon W plus P, W plus P. So this is the formula which is being modified, where what is W? W is the weight of the hammer in kilometer, H is the height of the freefall in centimeters, efficiency of hammer is given in percentage, S is the penetration per blow, penetration of the pile per blow, then C is the constant, W is the weight of the hammer, E is coefficient of restitution, and P is the weight of the pile is taken into consideration. So here, then another formula which is considered. Again, there are certain modifications, and that modifications are given by Hillis. Hillis is the one more scientist who gives the equation, that is Hillis formula. So third formula is Hillis formula. That is, third one is Hillis formula. So in the Hillis formula, the rest of the things which are neglected in the previous one is taken into consideration, where it is efficiency of hammer blow is taken in consideration. Hammer blow is taken into consideration, and that is efficiency of hammer. Efficiency of hammer, which is taken into consideration, and therefore the equation is QU is equal to W into H into efficiency of hammer into efficiency of hammer blow upon S plus C by 2. S plus C by 2. Now in this case, C is the different term, that is the constant which is taken into consideration the compression of the soil, compression of the pile, and compression of the pile, right? So here C is the constant which includes the compression of, it is not constant, it is the C is the total elastic compression of, one is pile, then pile cap, surrounding soil. So this is basically C is equal to, this is equal to C is equal to C1 plus C2 plus C3. So these things are given in the numerator, right? So here again it is being whatever efficiency of hammer blow. That efficiency of hammer blow is again depends upon the product of P and P. What is P? P is the weight of the pile cap. P is the coefficient of restitution. Now here first we will calculate E into P. Calculate E into P. So first criteria, when W is greater than, first A, when W is greater than E into P, W is greater than E into P, then it is being calculated by the equation efficiency of hammer is equal to W plus E square, W plus E square P upon W plus P. Efficiency of hammer blow is calculated by W plus E square P upon W plus P, and another one when W is less than E into P. W is less than E into P, then it will be calculated as efficiency of hammer is equal to W plus E square P upon W plus P minus W minus EP, W minus E into P upon W plus E square, W plus P its whole square. So this is the another formula which we can use to determine the value. So what is W? Sometimes instead of giving the W and P, W and H, the product of E, which is considered as rated energy. Rated energy. Sometimes instead of this, the things are given which is considered as rated energy, where the product of W and H may be given. So we will consider a small numerical in which the weight of the hammer is given. In the given numerical, we will solve all the things simultaneously. So here, the weight of hammer is given as example 1. W is given as 35 kilonewton. Rated energy is given as 3500 kilonewton meter. This, what is the value of H? Here, the value of H is then 100 centimeters. Then, length of the pile is given as 25 meter. Length of pile is 25 meters. Then, the efficiency of hammer is given as